Is AI, robotics, and verticality about to change farming as we know it? Welcome to Tech First with John Koetsier. So farming is going high tech, and we know that, right? We know about the drones, we know about the self-driving tractors, but what about the land? What about the process of growing? Vertical farming promises to use way fewer resources and to grow food closer to where we need it. And AI is helping. To see how plenty is changing how the world grows its food, we're chatting with co-founder and chief science officer, Nate Storey. Nate, welcome.
Thanks. Thanks for having me.
Hey, it is a real pleasure to have you. You are with your team right now in Wyoming, is that correct?
Yeah, that's right. Our science facilities are out here in Wyoming, so out here for the moment.
Excellent. Well, hope you're doing well there. Probably cheaper to have a facility there than Seattle, where I know you have some office space as well. But let's start here. Explain what vertical farming is and why we need it.
You bet. So, vertical farming is basically growing plants indoors under artificial light. And usually these systems are a bit more automated and they leverage a lot of tech in order to kind of condense production into these relatively small spaces.
Mhm.
These farms are usually focused on things like leafy greens, but we're working on things like tomatoes and strawberries and a bunch of other crops. And it's necessary because they're not making more land. The reality is there are 5 places in the world where you can grow fresh fruits and vegetables
Yes.
really economically, and all of that land is used up at this point. And there are water shortages, there are all sorts of other things. You start to think about climate change, and you realize our ability to grow more is pretty severely constrained. So vertical farming exists because we want to grow the world's capacity for fresh fruits and vegetables, and we know it's necessary. Americans are eating 50% of what they should be eating when it comes to fresh fruits and vegetables if they want to have a healthy diet. Globally, it's 30%. So we know people need to eat more. We also know we can't produce more. And so that's why vertical farming exists. It's our job to come in and grow that capacity.
Well, that's super interesting. I was just playing your video as we were doing that, and you said that plenty uses 1% of the land that a traditional farm uses. Where'd you come up with the idea of growing vertically, and how did you develop that?
Yeah. Well, I started in greenhouses. So I started kind of in the greenhouse space, focused on the greenhouse space. I was always drawn to figuring out how we could grow more with less. And greenhouses, 10 years ago, 15 years ago were the way to do that. And started my first company as I was finishing my PhD, and really realized that there was these incredible dynamic cost curves that were going into LED lighting and all of these other components of what we call indoor ag or vertical farming today. And for me, I felt like that was it was a pretty compelling path towards pretty incredible economics. And so 15 years ago, I would have said indoor farming isn't a thing. It can't be a thing. There's no way. It's too expensive. It's crazy. And then as you get to watch these cost curves in real time, you realize, holy smokes, you can see the future. Like the incredible thing about cost curves is you can see the future. You can see future economics. You can see the future cost of production. And when you couple that with massive latent demand and growing markets and constrained supply, wow, that's a heck of an opportunity.
Be explicit, maybe, if you can, at least as much as you can, when you're talking about those cost curves. What are you seeing? I mean, what's the, maybe even in general terms, what's the cost to grow a certain amount of leafy greens or whatever it might be in a traditional farming scenario versus maybe a greenhouse versus your vertical farming?
Yeah, so we're building a farm down in Compton right now. That farm
Straight out of Compton.
straight out of Compton,
Sorry, had
and
to.
and that farm will produce the equivalent of a little over 700 acres of production in terms of the value of that production. So we have the ability to condense an incredible amount into a very tiny space. And when you start to think about land, there's the obvious, like we're just incredibly intensive in our production. When you think about water, 99% of the water in the field that you put down is just lost to transpiration, right? Or evaporation. It's just evaporating from the soil surface, or the plants are transpiring that water. So it's lost. And in our farm, the plants still transpire, but we capture that water vapor. We're actually capturing that water vapor, condensing it, and recirculating it back into the system. So, just the fundamentals are very different than the fundamentals in the field.
Interesting. Very interesting. You mentioned 95% less water. You've mentioned 400 times more production of food in the same amount of space. Incredible numbers. So you can place a farm almost anywhere then, correct?
Yeah, I mean, the beauty of this is, the field is constrained, right? The field has to exist in a certain place. It has to exist with the climate that exists in that place, with the water supply, with the transportation infrastructure, whatever it is, right? Greenhouses are a little bit more flexible. Greenhouses can exist in more places, but they're still heavily dependent on the sun. They're still heavily dependent on, say, like cheap natural gas in northern climates, and the availability of water and inexpensive labor in more southern climates. And so, there are all these constraints on kind of these historical ways of growing these products. And what we do is we basically contain that in a box, right? We contain it in a giant box. And it works the same way no matter where we put it. Now, we might have to put a little more insulation on the building in this place or in that place, but functionally, everything else is exactly the same.
Yeah, yeah. Very cool. You're using AI to help grow your crops as well. What kind of AI, and what are you doing with the AI?
Yeah, so we have a lot of data that we have to grapple with, and the data that we deal with is incredibly complex. So these systems, I liken it to like building a space shuttle, right? We've got millions of parts. We have these processes that are super dynamic, and frankly, plants are an unruly bunch. You've got all this millions of genes that do all sorts of wild stuff. And, like these plants have evolved for, hundreds of millions of years to behave in certain ways and do certain things. And it's kind of our modern human arrogance that thinks we've got that under control. So, when you're dealing with these plants, the exceptions are oftentimes more common than the rule. They become the rule. So, when we think about the data that we have and how our systems have to manage that data and learn from that data, we can really only do that with really powerful tools. So, the team, we build our own software to manage, just the farm orchestration, all of the moving parts. AI plays a role in helping us understand data. What are the relationships between all of these different variables? And how do we optimize across this incredibly complex stew of inputs and outputs? And I will tell you, it can be very, very, very difficult to understand some of the stuff with more traditional statistics. We're not dealing with a limited set of variables here. It is practically unlimited.
It's amazing when you think about it, because I mean, for most people who don't think about it, frankly, and I count myself in that camp, right? You think, oh, how complicated is this? You have a seed, you provide some light, there's some water, you keep the pests out. What else? It kind of does it itself, doesn't it? So that's not accurate. Yes.
Yeah, I mean, it's accurate to a degree, right? Our problem is that we have to push yields. And we have to push quality to an extent that, we need to eliminate all plant stress. That's really hard, it turns out. We need to manage millions of plants at a time. That's really hard. We have these dynamic environments that help us do that. Managing that, the dynamic nature of those systems is really hard. And when you start doing things at higher levels, I think anyone can grow plants at low yield levels. That is not hard. Plants are set up to withstand a lot. But trying to grow them at some of these just, I guess, unprecedented growth rates, unprecedented qualities, that is really hard, it turns out.
It's amazing. My last episode, I interviewed the CEO of Insight Timer, which is an app for basically meditating and de-stressing. And you're talking about
Mm.
stressed plants, and I'm guessing plant stress is around not getting enough of something that it needs or getting too much of something. Is that correct?
Yeah, that's right. I mean, plants have like this optimal metabolic rate, right? Like you can maximize photosynthesis. You're not doing too much. You're not doing too little. It's peak kind of plant metabolism, and then you're managing that metabolism to put carbon where you want the carbon, right? Which is in your saleable biomass. You're managing the ratio of carbon to everything else, water to all of those other elements. And it's really easy to go too far. It's
Yeah.
also really easy to land under. And different plants are different. In our farm, we've got something like 12 different varieties growing at any given time,
Wow.
different crops and cultivars. And you kind of think, oh, kale, lettuce, they're all the same. At the end of the day, they're very different. They are different crops, and so you're managing across all these different requirements for each crop, and that could be really hard.
Very interesting. I'm going to show your video once again as well, and one of the things that you show in that is that you actually use robots as well. How do you use robots? How are they involved? Are they critical to what you do? And why are you using them?
Yeah, so I mean, they are critical to what we do. Like in that image right there, you saw a massive tower being picked up and hung
Hmm.
by the pickup robot.
Hmm.
Um, but we use a lot of other robots as well, and we liken it to the tractor. Right, when the tractor came along, it completely changed the economics and the possibilities of field agriculture. Right, it was the lead-in to the green revolution. Really, where we're increasing automation. We're figuring out how to get all of these inputs to different places around the world. We're improving genetics. And really what we've done here is we've kind of recreated the tractor just for this different farm, right? So in the same way that, back in the day, the guy go hop on his tractor and tool around the field. Today, our operators they're not sitting on a tractor, but they're operating, these robotics that are helping them process more plants and helping them, do work that humans are great at and not do the work that humans are terrible at. So,
Interesting.
yeah.
Interesting. So you already mentioned that with this technology, you can place farms wherever you want. You can place them close to people. You can minimize transit time, which is probably good for a lot of things. It's probably ecologically good, less fuel wasted. It's probably also good for the health and the quality of the produce that you're transporting, that it's quicker, farm to fork, as they say, right? How much space do you need to start a farm right now, and how much do you want? Like, what's the range of size of farms that you would consider putting in place?
Yeah, down in Compton, our farm is about a 2-acre farm. So there aren't a whole lot of 2-acre farms in the world,
No.
let alone ones that produce, what that farm will be producing. In the future, our farms will most likely be even bigger. So, we will most likely have farms that are 2 or even 4 times the size. It just kind of depends. But yeah, we anticipate more products to sell. We anticipate much more demand in the world. And we anticipate, serving much larger populations.
So you have a 2-acre farm in Compton. If that was a traditional farm, how many acres would it need to be to have the same output?
Yeah, it'd have to be, I think the last time we calculated out, around 720 acres for that particular farm. Now,
Wow.
it changes on the product mix, right? So like the more or lesser you produce of certain things, it changes the ratio because different things are productive at different levels. But we're always trying to optimize that product mix for the market and for farm economics. Yeah.
Interesting. If you set up a new farm or a 2-acre farm, and maybe this is proprietary information, I don't know, but if you can give me a general estimate, that'd be great. What's your cost to set up a 2-acre farm? I'm guessing it's not super cheap because you've got a building envelope, you've got all sorts of lighting, you've got the robotics to put in, and robotics are often like $50,000 per robot. But what's your general range of cost to set up a farm?
Yeah, you bet. So, we don't get into cost, but what I will say is it is cheaper to build our farms than it is to go buy the land to do the same level of production.
Wow. Okay.
Which is honestly kind of a false choice because that land doesn't really exist.
Yeah.
We're trying to build on top of that capacity. Like the field needs to keep producing. Our job is not to compete with the field. Our job is to grow the capacity of the world to feed people what they need. So I guess that's one way to put it, right? It is cheaper for us to build these farms than it is to go buy the land.
Excellent. Do you license your technology? Can somebody start a plenty farm somewhere wherever they want to, on another continent, in another country, or another place of the country where you're not?
Yeah. That's something we're thinking about. And obviously, we've got a lot of scaling to do. The idea of doubling to tripling the size of the current size of the world's vegetable production industry, that's massive. I mean, that's crazy huge. And so we have to do that. And we also have to do it in a certain amount of time. And so, what I will say is we're thinking very hard about the way to do that in the fastest possible way.
2 words for you: franchise farms.
Yeah, honestly, we may get there one day. The reality, though, is today, these things are very complicated and they are hard to run. And so until we have had time to really, build that technical expertise within our business, start to build that technical expertise and the understanding of why these things are necessary and what they are worth in the markets and other parts of the world, we'll probably be running and operating these farms.
That makes sense.
Yeah.
I mean, you can't really expand. It's like scaling, right? Any tech company can't scale until they really have it nailed in terms of what they're doing, how they're operating, what to do. And that makes a ton of sense. And I just said facetiously franchise farms, right? I have no idea what you're going to actually do or how you're going to do it. You're probably going to do it on a more sophisticated level. But when you're going to do that, you want to have a recipe for somebody who's going to come on board with you.
That's right.
Follow these steps and you have a 99.9% chance of success. Let's talk about where you are right now. I know you've got some stuff in Seattle. You're talking about Wyoming. Where are you active? Are you planning some expansion? And are you looking at bringing this to other continents, maybe other countries that have food safety or security or even availability issues?
Yeah, absolutely. So we're actually San Francisco based, so our headquarters are San Francisco. But I mean, we have a farm running in San Francisco. It produces and distributes in the Bay Area. We're building the Compton farm now. We're looking at a couple of other locations for the farm after that. So we're kind of in this process of scaling up. We did to your previous point. We took a lot of time to figure out how to do this the right way. There's no point in scaling something that's not economical. So taking the time and doing it the right way to get there, has been a slog, but we're there, and that's exciting. And after that second farm, we're really kind of focused on the U.S., right? Working with folks that share the same language. We understand, the laws and how to do it in the U.S. But that is ultimately the goal of this company, right? Like we have global aspirations, and we believe that in the United States we definitely need these farms. The rest of the world needs them even more.
Yep.
I think as we look at the crops that are becoming economical, these don't become farms that are just growing greens. Mm-hmm. These are farms that will soon be growing strawberries. We've talked about the Driscoll's deal quite a bit of late. These are farms that will be growing tomatoes and cucumbers and all of the traditional greenhouse crops. And I'll tell you, given the cost curves and where things are going, these farms will ultimately be able to move into crops that people thought were impossible, even just a year or two ago.
Wow.
So, I mean, I think we're looking at, to some degree, kind of the second green revolution here, right? Wow. As we cultivate, as we domesticate, all of these field crops over again, and bring them into a place where they can be super productive and grown anywhere.
What are some of the plants that people felt were impossible to do with vertical farming?
Yeah, I mean, I think for a long time, people have basically said, again, and this is just a misunderstanding of cost curves, but people basically said, okay, greens might be possible, but they have to be really expensive. And what we're showing is, one, greens don't have to be really expensive, And also many more things are possible. Like we signed this deal with Driscoll's because Driscoll's is looking at the technology saying, we see a future in which strawberries are grown indoors, right? And how do we partner on that? There are other berry crops. There are tomatoes. We've been breeding tomatoes for 2 years. Tomatoes will be economical as soon as we have the bandwidth and the focus to take them to market. We're going to blow people's minds. We're projecting an order of magnitude more productivity per square meter compared to greenhouses. Like, wow. That is a different level of production at a bricks that is 2 to 3 times the bricks or the sugar content of tomatoes currently in market. So, we're talking about orders of magnitude, different kinds of products, truly differentiated, both in terms of production and quality. And beyond that, there are crops like people would look at things like tree crops or lower value crops and say, like, there's no way that, say, the joke from several years ago was peaches. I think it was like a Wired article where they were talking with Matt, and Matt jokingly, joked about, well, we're not going to be growing a Georgia peach indoors. And they turned that into like, oh, well, we're going to be growing peaches indoors. And that was kind of an inside joke for a while. But I'll tell you, about a year ago, I grew a peach and gave it to Matt for Christmas, and that was kind of an inside joke. But the reality is, these crops have potential to move indoors. Like, people haven't thought of them outside of the traditional context. But as we look to the future, we see orchard crops. We see even commodity crops starting to make sense in certain scenarios. So, if you are a nation in this world that has limited food security, you have to import everything. The value of your food is quite different than it is here in the United States or other parts of the world, which means that what you're willing to pay for it is quite different. And what you're willing to pay for that independence and that control is quite different.
That's something that we've learned all throughout the supply chain for many different products in this era of COVID, where lots of products became difficult or hard to get. I'm guessing you talk about the cost curves and them starting to make sense. I'm guessing one of your biggest costs ongoing is energy. Is that correct? And how do you mitigate that?
Yeah, I mean, energy is a big cost, but again, it looks crazy until you understand the cost curves of electricity right now. Right. So, we were was talking with some ARPA-E folks, and they were just talking about how they are so interested in the space because, it's this global battle cry of electrify everything. Why? Because renewables are dropping in cost at a fantastic rate. They're displacing, fossil fuel generated energy, coal generated energy, natural gas generated energy. Like, those things are becoming more expensive than solar and wind. And I think we're just on the cusp of this renewable energy revolution. So, like, as we're looking to the future, just projecting out, solar energy prices, wind energy prices, there's a world where energy is more plentiful and cheaper than it is today, and also entirely renewable. So, we view ourselves as kind of positioning ourselves in a place to take advantage of that. In the field, diesel is diesel. You're stuck with it. If you're in a greenhouse, you're burning natural gas. You're stuck with it. In our farms, we're not stuck with any of those things, and we can use electricity. So, in our farms, we place a lot of emphasis on going out and sourcing renewable energy, and we'll be able to do that, for pretty much the entire foreseeable future for each of our farms. So, we'll be growing crops with renewable power.
Well, the beauty of that is that's kind of the old-fashioned way, right? I mean, energy from the sun,
yeah, that's right.
The earth, and the plants coming up. This has been really fascinating. I guess I'll leave you with one last question. I want you to project yourself out in the future. I don't know if it's 5 years, I don't know if it's 10 years, but at some point when that you've achieved or are firmly on the path to achieving your goals, what's that look like? How far out is that, and what's that look like, and how will you know when that moment comes?
Yeah, I mean, I think about that across a few different dimensions, but I think these conversations tend to center on the technology because the technology is really cool.
Yes, the AI, the robots, the verticality.
Absolutely, but the objective of all technology really should be to enable human joy. Right? It's to enable life, to give people, the best possible experience as a human being. And I think, for me personally, it comes down to how do you empower people to experience joy when they consume fresh food? And how do you tie people to places, to other people, to experiences, to moments in time with flavor? And you do that by giving them access to it at affordable prices. And so, like for me, it's the memory of being a child in the garden and eating carrot that my grandfather gave me that still has the grit on it, and the snap and the crunch and the flavor and the aroma, or a tomato from my grandmother's garden. And those experiences tie me to people that are they're dead. They're not with us anymore. But that's how I remember them. That's one of my experiences. That's part of me. And I think for everyone, if we can just deliver on giving them, the tiniest experience of that, then we've been successful. And you know what? If in the process we can defeat diabetes, if in the process we can defeat heart disease, if in the process we can help people live longer, healthier, happier lives, and if in the process we can help replace a lot of things that people have started to eat but really shouldn't be eating, then that's amazing. There's too many positive things to focus on just one. But we start with flavor. We start with building that relationship between people and their food. And technologically, we will be growing a lot of things that people think are crazy today, because they don't understand the cost curves. They don't understand what we're building. But the future will be quite remarkable. And I think the size of the global fresh fruit and vegetable industry will be will be multiples of what it is today.
That is a great place to finish. And I want to thank you for your time. I also want to thank you for the foresight and the vision and the mission that you're working on. It's impressive. And I wish you the very best. Thank you for joining us, Nate. I really do appreciate it.
Thank you.
For everybody else, thank you for joining us on TechFirst as well. My name is John Koetsier. I appreciate you being along for the show. You can get a full transcript of this in a few days, maybe a week, at johnkoetsier.com. The full story at Forbes will come out after that. And the video, of course, will be available forever on my YouTube channel. Thank you for joining. Until next time, this is John Koetsier with TechFirst.